Finally, we're going to learn to solve problems that have imaginary solutions. For these, notice that we don't have a middle term. We have an x squared term and a constant, but no bx term. So we're going to solve these with square roots. And remember, to solve with square roots, we need something squared on one side and a constant on the other side. So on problem number 11, the first thing that I want to do is subtract 25 from both sides. And that's going to give me 5x squared is equal to negative 25. I can go ahead and divide out 5. Remember, we want this as simplified as we can before we start taking the square root. So I'm going to have x squared is equal to negative 5. Let me rewrite that up here so that I have room to work. So I'm going to go ahead and do the square root of each side because I want to cancel the squared. So the square root and the squared cancel, leaving me with x on this side. But on the other side, I have plus or minus square root of negative 5. All right, I need to go ahead and rewrite that as plus or minus the square root of negative 1 times 5, because remember, we can pull that negative 1 out to the front as an I. So I'm going to be left with x is equal to plus or minus I times the square root of 5. All right, why don't you try number 12 and then come back here to see how you did. Let's see how you did on this last problem. So the first thing that I notice is that I have a constant on both the left-hand side and the right-hand side. I want to group those together on the right, so I'm going to add 10 to both sides. That will leave me with x squared is equal to negative 8, and then I'm ready to go ahead and take the square root of both sides. Remember that taking the square root of x squared is just going to leave me with an x because the square root and the squared cancel out, and that will leave me with the positive or negative square root of negative 8. I can rewrite square root of negative 8 as negative 1 times 8 under the square root, and the negative 1 under the square root will come out as an I in the next step. So I have positive or negative I times square root of 8. 8 is not a perfect square, but there is the perfect square of 4 hiding in that. How did I find that? By doing a factor tree. I broke 8 into 4 and 2. You can stop there if you recognize that 4 is a perfect square, or you can continue until you have the pair of 2's here. Once you have that, it gets rewritten as square root of 4, and then my everything else is a square root of 2. Finally, taking the square root of this perfect square, 4, leaves me with a 2, so my final answer is positive or negative 2i times the square root of 2.